Good morning, Mario. J Warriors. I know all of you would have checked the provisional answer key and probably your set of papers, but there were so many shifts, so many students who gave the examination, and all of them got different models or new questions and sometimes difficult, lengthy questions. So, going through all the shifts personally, I have collected all the top questions from every single shift which I felt were good or new or lengthy or on the tougher side, so that these questions will give you an idea of what is to come for the April attempt. And everybody is in the revenge mode, everybody is in the comeback mode, and of course when you have that plan or the strategy to come back, you obviously need to figure out where you fell short. You need to see what you did wrong. You need to see what you couldn't do. And these are exactly those kind of questions. Some questions are moderate but have some tricks or might have some new concept which you might like, right? So let's begin with the class, and do not forget to like this video right away right now. Yes, giving you 5-10 seconds, do that. Vanakkam Frederick. Hi Bharat. Yes, Bharat, Eklavya Test Series is one of the best, man. So many questions directly came from that. So, I mean, nothing better than that. So, let's begin with the class, and thank you for liking and subscribing. So, here's the first question. Consider two identical spheres. Charge is also there, mass is also there, separation is also there. Given initial speed, the minimum speed so that they can touch each other. So, I have just drawn a diagram, I think, somewhere here. Yes. So see guys, their initial separation is also given to me. Their initial separation is given to me, and that is 4r. Masses, charge, everything given. This has a speed u. This has basically a speed u. And when they touch each other, because I think the radius is given to be r, their final separation when they are just touching each other will be 2r, and just they would have come to rest because you push them towards each other, there will be a strong electrostatic repulsion which will slow them down, and when they just touch they stop, losing all their kinetic energy. So the logic to solve these questions is the kinetic energy initially plus the electrical and gravitational potential energy which is there initially will be equal to, finally there is no kinetic energy, it will be final electric plus gravitational potential energy. That's all. So if you see, all the options have capital G and Coulomb's constant both. That's how you get the idea. You have to consider the gravitational energy also. So kinetic energy wise, this is half m u square, but there are two masses, so into 2. Electrical potential energy will be Coulomb's constant q1 q2 divided by basically 4r. Gravitational potential will be minus g mm divided by 4r is equal to, finally when they touch, the electrical energy will be k q q divided by 2r, and gravitation will be with the negative sign g mm divided by again 2r. Solving this, you will definitely get the correct answer for the speed, which is going to be this one. Okay, solve this and you will get basically mu square is equal to something, and solving that you will be root of something. So that is how you solve this question. Is it clear? I'm not going to solve all the steps in today's session because the point is for you to solve this at the end of the day. I'm here to give you the procedure, the solution, the approach, the thinking, the thought process behind every single question. Yeah. Yes, Captain Ibu, you are going to have sessions for boards also on this, definitely. Okay. So, if I haven't solved Eklavya with my board preparation, can I get 150 in April? Yes, if you solve the boards and the preparation guide which I gave you, not just test series, I've made a strategy for your April comeback. Yesterday night only I had uploaded it. Yeah, Diksha was taking the class, so I couldn't conduct the class then. So I had to anyways plan for the strategy and I uploaded that video. Please check it out. So please follow those steps. Not just test series, there are many other things which I have told. And you can definitely get 150. 150 is not at all a big number when you have 2 months and a plan and a strategy. Okay, so let's go ahead to the next one. The energy of an electron is so and so. E naught is the ground state energy. If L is the angular momentum, H is Planck constant, then what is 2 pi L divided by H? Now, first of all, let's understand what the hell is this 2 pi L divided by H. So, see guys, 2 pi by H, I will write it as it is. Angular momentum is always NH divided by 2 pi. 2 pi, HH cancels. Basically, they are asking which principal quantum number it is. Many kids got confused when they saw this in the actual paper. And then some students were also not able to understand what was this. See, if E naught is the ground state energy and this is the energy in some nth orbit, and we know energy in any nth orbit is nothing but whatever is your ground state energy, into z square divided by n square, but I think here z will be same, so just divided by n square. This is given to be minus 0.04 E naught, and this is negative E naught as it is, divided by n square. Negative negative will cancel, E naught will cancel. 0.04 is 1 by 25 guys, yeah, and this is 1 by n square. So taking square roots on both sides, because n square is 25, it will become n is equal to 5. Hence, the answer for this will be just the number 5. Is that clear, guys? Option C is the right answer. Everyone? Yeah, the tests should be showing up probably by this week. And yeah, I think the start date for the test series is this week, because a lot of students will enroll after the provisional key. So I think the test dates were scheduled accordingly. Okay, cool. Shall we go ahead to the next question coming up on your screen? And here it is. As shown in the diagram, when the incident ray is parallel to the base, the emergent ray grazes along the surface as shown in the diagram. Refractive index is √2, then the angle of the prism is. Couple of things in this question. First of all, if I draw a perpendicular on the second phase, I know it is grazing incidence. So basically this would be, this R2 internal angle will be critical angle. So this R2 will be nothing but the critical angle, which is nothing but sine inverse of 1 by mu, and that means it is sine inverse of 1 by √2, and sine inverse of 1 by √2 meaning 45 degree. So the R2 angle, internal angle, is nothing but 45 degree. That is one piece of information I get, because it is given that the emergent ray is grazing, so it is internal reflection condition. Yeah, critical angle. Very good. Next important thing, because incident ray was parallel to the base, if this is 45, obviously this is also 45 degrees between two parallel lines. If there is an intercept, alternate angles are congruent, standard geometrical thing. So from this, if I probably drop a perpendicular over here, okay, so if this is 45 degrees, we can see that the angle of incidence is also 45 degrees. So we just need to figure out what is R1, the angle of refraction. Use Snell's law. So sine of I divided by sine of R is equal to refractive index, which is nothing but √2 as given in the question. Sine 45 is 1 by √2. This is 1 by sine R1 as it is. So taking on the other side, 1 by √2 and here 1 by √2 will be nothing but sine of R1. Therefore, sine of R1, 1 by √2 by 1 by √2, that will be 1 by 2. Therefore, R1 will be nothing but 30 degrees. Once I get that, I can get the final angle, which is the angle of the prism. There is a standard formula which says it is R1 plus R2. R1 is 30 degrees and R2 we just got it as 45 degrees. 3 plus 4, 5, 3 plus 4, 7, 75 degrees should be the answer. Yes, that is the correct one. Okay, so lot of geometry was involved. There were many shifts which had prism based questions and good amount of geometry involved. So if you think if you directly know the Prism formulas, you will be able to solve it. You are wrong, guys. There were many questions based out of geometry. Okay, so you should know all the properties of a triangle, parallel lines, triangle, what is that? In general, angles, whatever, supplementary, complementary, okay, how to solve any geometrical question. So these things you should know, guys. All right, let's move to the next question coming up on your screen. Okay, this integer based question which said Young's double slit experiment. There are two slits with some distance between them. Screen is 1 meter away from the slits. A sheet is introduced and a bright fringe is shifts by, the central bright fringe shifts by 20 millimeters on the screen. What is the refractive index of it? Now, there is a direct formula which you have to remember, guys. Yes, what is that direct formula? The shift which is encountered, the shift which you encounter is nothing but capital D divided by small d into refractive index minus 1 into the thickness of the slab. This formula, if you know, directly your problem is solved. Now, why I'm doing this is because there was, hardly any question on the shift in the last couple of years. So students had forgotten it. Students took it very lightly. They did not do these questions. But it has made a comeback. So there is a good chance such kind of comebacks can happen. That is just to show you that. So the shift which happens is 20 millimeters. So millimeters means 10 to the power minus 3. Capital D is 1 meter. Small d is 0.4 into 10 to the power negative 3. Over here, refractive index is unknown and the thickness is 20 micro. Micro is 10 to the power negative 6. The only unknown over here is the refractive index. So solving it, you will get the answer as 1.4. Yeah, solving this, you get the answer as 1.4. But here they are asked, the refractive index is alpha by 10. So that means what is the value of alpha? So this will be 14 by 10. So 14 is the value of alpha. Yeah, that's it. 14 by 10 is 1.4. So answer will be 14. Understood how to solve this question? Okay, so remember this formula. If this is not there in your formula sheet or book, please copy paste it. Moving on, next one. An electromagnetic wave is propagating through a medium of some conductivity. The ratio of maximum conduction current density to maximum displacement current density. This is a new model of question. This is definitely a new model of question, guys. This is very good question. Yeah, let's try to understand it. See, if there is some kind of a medium, if there is some kind of a medium, and in this medium, what is happening? Our electromagnetic wave is propagating through that medium. Then the ratio of the maximum conduction current to the displacement current. Well, let's understand how do I find out conduction current density. Conduction current means regular flow of charges which happens. That is your conduction current. That density, meaning your regular current density, that is what has been asked. Now there is a direct formula. If you remember, yeah, just like you have voltage is equal to current multiplied by resistance. If you use resistivity, this will become current density. This will become electric field. If you take rho on the other side, 1 by rho into E will be J. Therefore, our J will be E multiplied by 1 by rho is nothing but sigma, which is your conductivity. Yes, this 1 by rho is nothing but your sigma, which is nothing but your conductivity. Now, if I want J, which is the maximum conduction current density, I will need the value of E, and that E is nothing but the electric field. So, electric field is obviously there in an electromagnetic wave. And that electric field equation is generally E naught, let's say sine omega t, right? E naught sine omega t. That's how it is going to vary at any single point. So that will be your general J. So if I rearrange the general J, it will become sigma E naught sine omega t. If I want the maximum value of the current density, sine maximum value is 1. So it will be nothing but sigma multiplied by E naught. Just check this out. Do you guys agree with this? Yeah. Do you guys agree with this statement? Pakka? Yeah. Everyone? Sigma multiplied by E naught will be the maximum current density. Very good. Now comes the next part. Okay, I think I might need 2 slides just to show you what is happening. Now look at the second part, which says, can you tell me now what is the maximum displacement current? Maximum displacement current. Now, displacement current has a generic formula. What is the generic formula for the displacement current, my dear warriors? Yeah, it is nothing but permittivity epsilon naught into rate of change of electric field, right? Rate of change of electric field. Is that right? Everybody with me on this? The displacement current will be electric field multiplied by area, which is basically your flux, and that is your displacement current. Just check this out. Yeah, rate of change of electric flux multiplied by permittivity. Yes, that gives you a displacement current. Now, area, if I take it outside for a minute, and in fact, I shift it over here. So this will become ID divided by A is permittivity multiplied by DE, rate of change of electric field. Now, this quantity is exactly what we want, maximum displacement current density. So current by area is density. So this is displacement current. Whereas, where is it? This one was your conduction current. Keep that in mind. So JD will be nothing but epsilon naught into dE by dt. But electric field, as we know, it is E naught sine omega t. So what will happen is epsilon naught will come out, electric field amplitude will come out, sine's derivative will be cos of omega t, and that omega will also come out, and that will be JD. But we want JD max. We want JD max, that will be only this term because cos maximum value is 1. So epsilon naught E naught into omega. Now comes the final question, which asks me ratio of these two things. So the conduction current maximum density divided by the displacement current maximum density. That will be nothing but, so we just got J max is sigma E naught. This is sigma into, not epsilon naught, E naught. And this one is permittivity, field amplitude into omega. E naught will cancel, and you will have sigma divided by permittivity into omega. So sigma is already given, which is 10 ohm, I think. It is not MHO. Ohm, it should be. Spelling mistake is there, I think. Yeah. So 10 is there, and therefore epsilon naught, which is standard 8.85 into 10 to the power minus 12, and omega is nothing but 2 multiplied by pi, which is 3.14, multiplied by the frequency, which is nothing but 100 megahertz, so into 10 to the power 6. So solving this, you will get the right answer. So you get the answer, I think, as 1800. Yeah, you will get the answer as 1800. That is the right approach for solving this question. It's a beautiful concept, new model kind of question. So looking at conductivity, we need to understand that conduction current density, meaning your regular J which you use in current electricity. So current electricity question coupled with electromagnetic waves, it's a beautiful question, guys. Okay, very few people were able to get it. Yeah, how many of you loved the new model? Yeah, isn't it amazing, guys? So we saw that electric field was involved. Electric field is there in electromagnetic wave. So regular expression of electric field we substituted. So we got a generic expression, but since maximum was asked, we only checked the amplitude part of it. In the second step for displacement current, we use regular formula for displacement current, which is permittivity into rate of change of electric field into area, which is basically electric flux. But area, if I take it below here, then that becomes current per unit area, which is density. So differentiating it, we get the expression for maximum. And then you just have to take the ratio. Best part, epsilon naught is remaining, omega is remaining, sigma is remaining, but E naught, electric field, just got cancelled out. Let's go to the next one. Potential energy versus distance is given by the graph. Rank versus regions as per the magnitude of the force acting on the particle. Now the force will be, let's say, charge into the field, and field is nothing but minus dV by dr. But if I'm interested only in the magnitude of the force, it will be Q into just dV by dr magnitude. That means it is Q multiplied by whatever is the slope's magnitude. So I'm interested in comparing only the magnitude of the force. So I should look at only the steepness of the slope, not the positive negative value. Obviously, looking at it, the least slope is with CD. So this is 0. This has the maximum slope, which is BC. This AB has, I think, 1:1. This is 2:1. Yeah. So this is medium. So B to C will be maximum. B to C will be maximum. So B to C will be maximum. And C to D will be minimum. So C to D will be 0. So yes, option A will be the right answer. You don't even have to check others. But anyways, you can see O to B, or rather whatever, A to B will be slightly higher than D to E, because A to B is steeper, D to E is not that steep. That's it. Very obvious. Looking at the graph only you can get it. Yeah. Well, if you got all these questions in your shift, that means what do I say? You guys are a legend. You guys are a Sigma if you solved it. Okay. Oh, by the way, I have put the questions sequentially. So you will see the initial questions are from 21st, 22nd, and then later on going to 23rd, 24th, and then finally the last questions are from 28th. So you will see a natural flow. So you might see a lot of questions from your shifts in one stretch. Okay, that's quite possible. Okay, guys, shall we go ahead to the next question then? Ready? Okay, let's go then. Here comes the next question, number 7. There was some loop given placed perpendicular to the field. If the resistance is also given, the question was what is the average thermal energy of the loop? So essentially the magnetic field was perpendicular to the plane, and it is changing inside that loop. So there is change of flux, because of which there will be EMF introduced, and because of that there will be energy which will be lost, because the wire has a resistance. So how much energy is lost in one time period? That is what has been asked. Okay, let's try to figure out the basics first. How much is the EMF? Okay, so EMF will be nothing but rate of change of magnetic flux. So magnetic flux means magnetic field into area. Area will go outside, and I will have dB by dt over here. So area outside, dB by dt means it is what? Derivative d by dt of sine of 100t, and this area is also given to me. Area is 1 meter square, so area goes outside. Okay, so therefore my EMF will be derivative of sine 100t, that will be cos of 100t, and that 100 will come outside. So this is nothing but maximum voltage. This is nothing but maximum voltage, but we will need the RMS voltage, which will be the maximum divided by √2 for calculation of thermal energies. So let's start with thermal energy calculation. First, let's look at the power. The average power will be nothing but ERMS square divided by resistance. So it will be 100 by √2. This whole square divided by the resistance, which is 100 ohms. One of the hundreds will cancel, so 100 will be there, and this √2 square will be 2. Yeah, 100 square and 100, one cancelled, one remained, which is nothing but 50, but this will be watts. Now comes the final aspect, where we talk about the energy in one period. So what is the meaning of one time period? So one time period is nothing but 2 pi divided by omega. So omega over here is nothing but 100. Omega over here is nothing but 100. That means it is pi by 50. So when we talk about energy, energy is nothing but the power multiplied by time, because power is energy by time. Power is nothing but 50, and the time is nothing but pi by 50. Time is nothing but pi by 50. 50-50 will cancel and the answer will be pi. This will be in joules, not in watts. If wattage was asked, it would be 50. If power is, if energy is asked, it will be pi. So hence the answer is option C. Okay. So nice question. Usually they ask power, but here they have asked energy, which is given in one time period. Yes, you have to multiply by time. Yes, you are given. Yeah. How many of you had this question, guys, in your shift? Let me know quickly. Moving on to the next question on your screen. Here it is. Just 1 second. Let me just save, because what is happening, sometimes the board will hang. So I'm just going to save it so that I don't lose my work. In a microscope, the objective is having some focal length, eyepiece is having some focal length, the tube length is given, the magnification produced by the microscope for normal adjustment. Last year, not even a single question came on optical instruments. People left it, but I told you, please don't leave it. This time I feel it might come. And this is exactly what happened. In fact, there were two microscope questions in one of the shift and another shift also. So, and there were questions on telescope also. So yes, it has come couple of times. So let's understand how do we do this. The magnification produced by this microscope, basically the magnifying power of a microscope is nothing but the magnification of the objective multiplied by the magnifying power of the eyepiece. Now the magnification of the objective is nothing but VO divided by UO. Magnifying power of the eyepiece for normal adjustment will be least distance of distinct vision, not 1 plus D. 1 plus D will come for closest distance of approach. When normal adjustment is there, it will be D by F. That's how a simple microscope works. So D by focal length of the eyepiece. But what happens is, in approximations, these values I already know. This will be the length of the tube, and this will be nothing but the focal length of the objective. Focal length of the objective. That's it. So length of the tube is already mentioned. It is 32. Focal length of the objective is 2. Okay. Least distance of distinct vision is 25. Focal length of the eyepiece is 4. So 32 by 2 is 16. 16 by 4 is 4. So 4 into 25, which is nothing but 100, guys. So the answer will be 100. Yeah. Okay. So in general, the magnifying power of a microscope is magnification of objective, number 1, multiplied by magnifying power of the eyepiece. So what happens is, this quantity is 1 plus D by Fe if it is least distance of distinct vision. But if it is normal vision, then that 1 plus will not come. It will just be D by Fe for your regular normal vision when you are focused at infinity. This magnification is your regular formula, which is image distance by object distance. So this is image for the objective upon object distance for the objective. Objective is the lens which is closer to the object that you are scanning. Now, the approximation is, in a regular microscope, the image is formed very close to the other side. So almost the image distance becomes the length of the tube, and the object is usually kept very close to the focus. So that becomes the focal length. Okay, so object distance becomes the focal length. So that approximation you should know. If you know it, it becomes easy. Is that clear? Okay, Coulomb. Yeah, this is the formula, man. Okay, you guys forgot, so now I have told you this. Okay, perfect. Moving on to the next question. See, in many books, some weird formulas are given, and they give it in different ways. I would suggest, if you want to complete optical instruments, just go to the channel and write optical. Even if you write optical, I think it is more than enough. Oh, it is showing other things. This marathon I had conducted, this is something which you can do. Human eye, microscope, telescope, one shot. Please go through it. Okay, please go through it. Optical instruments, one shot. Properly I have done it. Yeah, it's a beautiful session, and I have explained every single thing. Okay, right from human eye to microscope to telescope. Okay, so please go through it. Right, everyone? Okay. Perfect. Next, let's go to the next question. Huh. Now, this question is actually debatable. If if you really think you can actually claim and challenge this question, but I know NTA people will not accept their mistakes, so no point arguing about this question. So don't challenge it. But logically speaking, this question should be challenged, because I think most of the people have solved this question in a wrong way. And when I discussed this question also, I had told that what is the general mistake. Three small identical bulbs of water with the same charge on each coalesce to form a bigger bubble, then the ratio of the potential on one initial bubble to that on the resultant bigger bubble. So what people do is the ratio of the potential on one initial bubble to the resultant bigger bubble. The common mistake, I'll come to that, but before that, let's talk about the potential energy. The potential energy is given by S into A, United States of America. That's the easy way to remember. So it's proportional to the area. So the initial bubble upon the final bubble means the initial area upon the final area. What is the initial area? It is a bubble, so it will be having 4 pi, and r might be the radius, let's say, so 4 by r square. But a bubble will have two surfaces, one inside and one outside. So to account that, I'll multiply by 2. So why is this 2 coming? Because there are in and out surfaces for a bubble. That's why multiply by 2 divided by the final surface. Oh, but wait a minute. There were 3 small bubbles. So there were 3 bubbles. So multiplied by 3. Finally, there is only one big bubble. So 4 pi r square, but there were only 2 surfaces. Again, the same logic, what I have used over here, will be used here. Remember, there were 3 bubbles. So that's why 3 surfaces should be considered. You will notice 4 pi 2 will cancel. So you will be just left with 3 small r by capital R whole square. So now the whole problem comes down to what is this ratio of r by r. Because if you get the answer, then your job is done. Nothing is there. Correct? Now this is where the next actually thing comes, and many people made a mistake in this. Many people have written down volume is conserved. In fact, the NTA solution also expects the volume to be conserved. But guys, no, initially there were 3 bubbles and they are combining to form one bubble. The ratio of the, oh, sorry guys, these bubbles were charged. My bad. I was talking about surface potential energy. My bad, my bad, my bad. So sorry. Redoing it. So sorry. I was doing surface potential energy. I did not read the word potential. My bad. The ratio of the potentials on the initial to that on the final. Okay. So if you talk about potential on a bubble initially, that will be Coulomb's constant. Each bubble has charge Q and R. So that will be the initial potential on any one of those bubbles, number 1. So I can call it as, let's say, V1. Now, because charge is conserved, since charge is conserved, so the final charge is basically 3Q. Q plus Q plus Q is 3Q. Next, only problem is the radius. So the potential on the final bubble V2 or V final will be K into charge, which is 3Q, divided by the new radius. So when I take the ratio V1 by V2, what will happen? I'll get KQ divided by small r, and over here K 3Q divided by capital R. KK will cancel, QQ will cancel. So I will get 1 by 3 over here and capital R divided by small r. Till this point, absolutely clear, everyone? Yeah? Till this point, absolutely clear what we just did? Electrical potential we are talking about, not the surface potential energy. Yeah. Now, the problem is, what is this R by R? So for that, many people used volume conservation, which I feel is wrong, because imagine this, when you have these bubbles and they become a big bubble of radius r versus small r, how is it the volume is conserved for a bubble because inside there is air and air is expandable. It can be compressed or it can be expanded. So because of which, when you use a compressible fluid, volume is not conserved, moles is conserved. So ideally speaking, the moles are conserved. Moles are conserved. So n plus n plus n is equal to capital number of moles. So 3 times small n is capital N, we can say. And then what happens is that moles is nothing but PV is equal to nRT. So n is PV by RT. So pressure initially into volume initially divided by RT will be 3 times pressure finally, volume finally, divided by R into T. Now, gas constant and temperature will be the same. Sorry, 3 is not required here. Yeah, R and T will be the same. So, ignore that. So, what is that pressure inside? That pressure inside is the outside pressure plus 4S by R. Yes, plus 4S by R. And volume initial will be 4 by 3 pi small r cube is equal to pressure inside this will be outside pressure plus 4s by capital R, and this will be nothing but 4 by 3 pi and then capital R cube. This is what the actual expression should look like. But then here comes the approximation which many people missed and they wrote it directly without even thinking what is happening in the question. This outside pressure is generally of the order of 10 raised to 5 pascals. This quantity is not even 1 or 2 pascals. It's barely anything. So when you have such a big term versus a small term, that small term becomes negligible. So that's why this expression becomes negligible. But even before doing that, let's cancel 4 by 3 pi and 4 by 3 pi. So what you actually end up getting is 3 times of P naught multiplied by R cube is P naught multiplied by capital R cube. Do you get my point? P naught plus this entire quantity, this becomes negligible. 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 That is the whole purpose of this problem. Okay. Although you might write volume is considered and still get the right answer, but you should know why volume approximately is considered, not exactly considered because of this approximation. Anyways, this value of P naught now will get cancelled off, and therefore from this I will get my R by small r. R by small r will be 3 raised to 1 by 3. Once I get R by small r is 3 raised to 1 by 3, I can put over here 3 raised to 1 by 3 as it is, and of course divided by 3. So, if you take it below, it will be 1 by 3 raised to 2 by 3. 1 by 3 raised to 2 by 3. Yeah, which is exactly option D. Got it, guys? How to solve this? Isn't it amazing? The moles were conserved. The moles were conserved. And this term was negligible. And P naught got cancelled. So we got the ratio of R by R. And from that, we substituted R by R over here. And then we get it correctly. Yeah. Loved the question, I hope. Yeah. Amazing, right? Okay, fine. Let's move to the next one on your screen. Alpha particle hits the target material. Estimated diameter of the nuclei of the target material is approximately how much? See, this is based on Rutherford's experiment. Basically, you have a alpha particle. Alpha particle means plus 2e, and it has some energy. It goes, and just stops over here. And this is your target nucleus. This has 79 E charge, positive 79 E charge, and it just stops before returning. And the question is, what is the diameter? Well, we know, first of all, this is nothing but the radius, and this is nothing but the diameter. We have been asked what the diameter is. So all you need to do is, the initial kinetic energy will convert into electrical potential energy. Use this formula. Kinetic energy is already given 7.9 mega electron volt. So 7.9 mega is 10 to the power 6. Electron volt is 1.6 10 to the power negative 19. Electrical potential energy is 9 into 10 to the power 9, which is Coulomb constant, multiplied by charge 1, charge 2. So 2e multiplied by 79e, the whole thing divided by your r square. Sorry, just r, my bad. You will also see one thing, that this 1.6 10 to the power minus 19 will cancel with this, because that is also the same value. Solving it, you will get the value of r, but you have been asked d, so d will be nothing but 2 times of r. So solving that, you will get the answer. Okay, you get the answer as 5.76 10 to the power minus 14. Okay, so you'll get 5.76 10 to the power minus 14 meter. It's very straightforward, but you should understand it's a question on Rutherford's model of atom, where gold foil is there, and the nucleus is being bombarded with alpha particles. Closest distance of approach concept comes in that atomic structure chapter, coupled with electrostatics. Yeah, that's all. No, no, no. It's not a question on nucleus, guys. It's not a question on nucleus where R radius is capital R a raised to 1 by 3. No, no, no. Don't use that. Okay. Right. Perfect. No, no. We are not doing for NEET, man. This is for JEE Mains. Okay. Now, moving on to the next question. This was also a good question. Although this was asked long time back. I'm doing it because some people might have stopped or forgotten these models of question. So it's made a comeback. So you also need to make a comeback. There is a smooth long loop having resistance of R, Px, Px is parallel to Qy. Px is parallel to Qy. Separation is L, resistance is R, magnetic field is there, and the rod of length CD is falling down with gravity, and the terminal speed is how much? See, why will there be a terminal speed? Is because there will be mg force which will be acting down, and because of the current which is induced, there will be an ILB force acting upwards, because of which you will see that the velocity will be constant. The velocity is going to be constant, meaning the acceleration is 0. So the forces must be balanced. So therefore, you will see that our ILB force will be balanced by mg. Will be balanced by mg. Current is nothing but the EMF which is induced divided by resistance. So into L into B is equal to M into G. So L into B divided by R is equal to mg. Only thing remaining is E induced. Now for E induced, the logic is, for E induced, it will be nothing but BL into V. This is nothing but your motional EMF. Motional EMF. So just substitute BLV over here, and from this you will get the value for velocity. So R goes on the top, mg also is on the top, L and B will get squared. So L square, B square. So R mg divided by B square, L square. That should be the answer, guys. As simple as that. Okay. Fair enough, everyone. mgr divided by L square, B square. Cool. Amazing, 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 amazing. Very nice. Wait. Constant magnetic field. Okay, yeah. Now, the next question, guys, let's go ahead. What is this? This one. A cylindrical tube of certain length is closed at both ends and contains an ideal gas of 1 mole having weight. Tube is horizontal, angular velocity is omega. Okay, if P and PB are the pressures, consider the pressure relationship between them. Okay, okay, fine. So how do we do this? Well, I know for a fact once you rotate it, the gas will be thrown out. So the gas density will be higher here, it will be lower here because of the centrifugal force. So the pressure will keep on changing because of the pseudo gravity experienced. Now there is a formula which talks about how pressure changes with height along gravity or the perceived gravity. Do not say P is P naught plus rho gh. That is the final result. There is a rate of change of pressure formula which is called pressure gradient. Yeah, that formula is in the beginning of hydrostatics. dP by dx is nothing but rho density into gravity, which is experienced, the apparent gravity. Now, here, if I am standing at some location x, at this point, the gravity which is going to be experienced is because of the centrifugal force. So, the G apparent gravity will be omega square x. This is due to the centrifugal force. Due to the centrifugal force, omega square r will become the centrifugal gravity, you can say. So because of which I can write this as rho into omega square x dp, and that dx will go over here. Obviously, next step will be integration, and here also integration. But before that, there is a problem. Density is not a constant, so I cannot take it outside. So dp will be, because there is a gas which is filled inside. Remember, there is a formula in ideal gas. Yeah, and it says Pm is equal to rho RT. So rho will be pressure into molar mass by RT. Okay, so let's use that. So instead of density, it will be pressure into molar mass divided by RT, omega square x dx. Take pressure below over here. So dP by P will be capital M omega square by gas constant into temperature into x into dx. Now comes the time for your integration. So when I'm at pressure A to pressure B, my x will change from 0 to L. This value is 1 by x integration, which is log of x. So it will become ln x. So log of upper limit minus log of lower limit, subtract, is equal to m omega square by RT, and this will be nothing but x square by 2, which means it will become L square by 2. That's it. So this will be nothing but PB by PA, which then can be written down as PB by PA e raised to, yeah, it will become e raised to m omega square L square divided by 2RT, divided by 2RT, because log of PB by PA, if you expand it, you will exactly get this. So PB will be PA into e raised to this, which is, I think, this particular option C. Yeah, perfect. There you go. So logarithm based question coupled with yeah, integration and all of that. So it's a nice question because many kids usually skip the part where density is variable. They miss this part and they take density as constant, and you get a completely different answer then. Yeah, so that's it. It's a very nice question. Moving on to the next one coming up on your screen. Electric field in a region is given by some equation. A is some value, B is some value. Electric potential is this much. At some point, what is the potential at origin? This kind of question, although procedural, might have been forgotten. So just to remind you, because some mistakes can be done, I'm doing it. So first of all, my electric field is nothing but 10. So 10 x I cap. B is nothing but 5. So 5 y j cap. Okay. Now, what we can do is that electric field and potential, they are related by derivative. E is dV by dr. So I can say delta V is negative E dot dr with integration. So negative is there, and electric field is your 10x I cap plus 5y j cap. Dr vector is dx I cap plus dy j cap. Okay, perfect. This is final minus initial. So finally, let's say I'm at this point. Initially, I'm at some other point. So this particular Vp minus V origin will be negative. When I do the dot product, 10x will multiply with dx. So I will have 10x dx integration, and 5y will multiply with dy, so minus 5y dy integration. Initially I was at origin, finally I will be at this point 10 comma 20, so x coordinate is 10, y coordinate is 20. That's it. So this potential is given to be 500 volts. The question was, what is the voltage at origin? That's it, guys. It's now a simple integration problem. X square by 2 will be the integration. So which means it will be 10 square by 2 minus 5 into y square by 2. That means it will be 20 square by 2. That's it. So solving this, you will get the voltage at the origin. So just check it out. You will get it as 2000 volts. That's it. You will get it as 2000 volts. Okay. So this formula is important. Voltage difference is negative E dot dr, and dr is a small displacement. So dxi plus dyj. Electric field was already given. Do the dot product and integration. When you integrate with x, only integrate the limits of x. When integrated with y, integrate only the limits of y. So I have taken the y coordinate over here, and here I have taken the x coordinate. That's all. So that is the only place where confusion can happen, if at all. Cool. Shall we go ahead to the next one then? Okay, perfect. Let's move. Next question, guys, on your screen, here it is. Two loudspeakers are placed with the separation. Both speakers are given some input, frequency, volume, voice is, a recorder is placed at point A, equidistant, and then moved here. And while you move it, you are undergoing 10 cycles of minima and maxima, the frequency of the input signal. This is such a brilliant question because it looks like a Young's double slit experiment if you forget the word sound and replace it with light. So imagine two light sources and you're going from here to here. You are seeing 10 cycles, meaning there are 10 fringes over here. So the moment people realize, oh, it's just like light, so people jumped into the conclusion, I can use fringe width formula, which is lambda d by d. And then they thought there were 10 fringes here, and they equated it and got the answer, which is completely wrong. See, you should understand what is the fundamental difference in Young's double slit versus this kind of apparatus. The difference is this separation, this distance, and the wavelength. They are all comparable. There is no approximation involved here. When you derive the fringe width, the path difference in Young's double slit, there were so many approximations. Capital D much larger than small d, which is definitely not true. Wavelength is very not comparable as compared to the distance between the slits. It was very small. All these things are no longer applicable. So very important. This is like a very good question because a lot of students will get caught in it. Don't use YDSE since lambda d d are comparable. They are comparable to each other. Okay. Yeah. All right. I would wish to Sudhakar, but it seems like it is not possible, at least for now. I really hope to. Yeah. With all your favorite teachers, but it doesn't look like it is happening right now. Okay. Not now. All right. Moving on. See, don't use YDSE. Okay. I told you. What you need to do then, I'll tell you. You need to go by the basics. You need to literally calculate what is the distance L1 and what is the distance L2 and subtract them. There is no other choice that you have. And for that, drop this perpendicular, figure out the hypotenuse in these two triangles. That's it. There is no other option. Okay, there is no other option. So if you look at L1, L1 square will be this square, which is 40. So 40 square plus this much. Now see, this is 10, right? So if this is 10, it is natural that this much will be 5 and this much will also be 5. Is that right? From here to here. If this is 5, this is 25. How much will this be? Just think about it. From 25, 5 goes off. So this much will be obviously 20. And if you ask me how much is this entire thing, This is 25 plus 5, so that will be 30. So that will be 30. So these lengths will be needed to solve the question. So it will be 40 square plus 20 square. So from this you will get L1, which is the root of 1600. 20 square is 400. So root of 2000. So root of 2000, guys, is nothing but 100 multiplied by 20. So I can factorize it as 100 multiplied by 4 multiplied by 5, correct? Because this is root of 2000. So this will be nothing but 10 into 2, which is 20. So 20 root 5 is nothing but the value of L1. Is that okay? 20 root 5. Similarly, find the value of L2. L2 will be nothing but, using Pythagoras theorem, L2 square will be 40 square plus, how much is this? 30. Yeah, 30 square. Oh, this is standard. So L2 will be nothing but 50. 435, guys. 435 triangle, 3, 4 and 5. So this is 4, this is 3, this will be 5. So 30, 40, 50. Pythagorean triplet. Okay. Once I get this, from here I will get the path difference. The path difference, that will be delta L, which will be L2 minus L1 in this case, which will be 50 minus 20 root of 5. Now from this, what we need to do, I'll tell you, once I get the path difference. Since I move 25 meters and I'm getting 10 cycles of maxima and minima, one cycle will correspond to one wavelength. 10 cycles, so one cycle corresponds to one wavelength. 10 cycles will correspond to 10 wavelengths of path difference. Is that right? So I can definitely say that 10 times of lambda, 10 times of lambda will be the path difference, which is delta L, and that delta L, we got it over here, 50 minus 20 root 5. So 50 minus 20 root of 5. What is the wavelength formula, guys? Speed of sound is speed of sound is nothing but f into lambda. So lambda will be v by f. So it will be v divided by your frequency, and I think the frequency is asked. So that's what I'm slowly converging on. So f will be 10 multiplied by v divided by 50 minus 20 root of 5. But I think the speed of sound was given to you. If I'm not wrong, just see if it is given somewhere. Yeah, speed of sound is 324. So this is nothing but 324. 10 multiplied by 324. And root 5 value is also given 2.23. So just put that over here, which is 2.23. Solving this, you will get the answer. Yeah, you will get the answer as 600 hertz. Yeah, you will get this answer as 600 hertz. Okay, it's a beautiful question because YDSC was not applicable, and you had to literally go by geometry by using Pythagoras theorem to literally figure out the paths and then the path difference, and then realizing 10 cycles means the path difference is 10 lambda. So whatever path difference you got was actually 10 times of lambda, and lambda is related to frequency. Yeah, got it? Awesome. The same session for chemistry was done yesterday, man. The same session was done for chemistry yesterday. Yes. All right. Moving on to the next question on your screen. Here it is. Question 15. The electric field of a plane electromagnetic wave traveling in an unknown non-magnetic medium is given by so and so. What is the dielectric constant? Okay, directly, guys. See, dielectric constant means you need to know the speed of light. From that only you'll get the answer, because we know that the speed of light in any medium is speed of light in vacuum divided by your relative permittivity into relative permeability. Now, the speed of light in vacuum is 3 into 10 to the power 8. Relative permittivity is only the dielectric constant. Permeability is 1. If I know this, my job is sorted. So, what you do, this is nothing but your omega, this is nothing but your k. So, speed of sound in that medium is omega by k. Omega is 4.5 into 10 to the power 14. K value is 3 into 10 to the power 6. So how much are you getting, guys? 45 by 3. It will become 1.5, okay, into 10 to the power 8. So this is nothing but 1.5 into 10 to the power 8. Solving this, you will get the answer, of course. Yeah, only thing unknown is K. So you can see root of K will become 3 divided by 1.5, 10 to the power 8 will cancel. So this is 2, that is root of K. So K will be nothing but 4. So the answer should be 4. Yes, perfect. The answer is 4. Cool. Amazing, guys. Amazing. Amazing. Many of you got it. Very good. Shall we go ahead to the next question then? Shall we go ahead to the next question on your screen? And here it is. It says, when a part of capillary tube is placed vertically in a liquid, the liquid raises up to a certain height. If the inner radius, density, and surface tension increase by 1% each, then the height of the liquid in the tube will change by how much? This was a good question, otherwise simple, because there is a chance of a silly mistake, and I want to highlight that. So see, guys, the height is given by 2s cos theta by rho g r. So delta h by h in percentage will be, forget 2, it will be delta s by s in percentage. Cos is not changing, plus delta rho, I think density is changing. Oh, if the inner radius, density, and surface tension, okay, G is not changing, that's all. So delta rho by rho percentage plus delta R by R percentage. Now this will be the normal formula which you use in errors. And in errors, what happens? You try to figure out if S, rho, or R will change. What is the maximum possible error percentage that you can get in height? So there, every term will always be added. Never will you see any term being subtracted. But the catch is over here, all these quantities are decreasing. So if surface tension reduces, the height will reduce. So surface tension has a negative contribution. If density reduces, then the denominator will reduce, the height will increase. So this has a positive contribution. If radius reduces, denominator reduces, again height will increase. This has a positive contribution. So this is the correct sign which you should put instead of just minus and instead of just plus and plus. So what will happen is this surface tension is contributing negative 1%, density is contributing positive 1%, radius is also contributing positive 1%. So hence the final contribution will be 1%, and since it is positive, it means it will increase. So hence the correct answer is option B. Got it? So the sign is the place where many kids make up a mistake. Yeah, that's how you do it. Moving on to the next one. The diagram shows a circuit with multiple resistances, the reading of the ammeter when the switch is turned on. Now, what happens in this kind of questions is, the moment you turn on an inductor, the inductor behaves like a open switch. It behaves like an open switch, because of which this part will not have any current, this part will not have any current. So whatever current has to flow, it will flow here only. That's it. The moment you close the switch, and that current will be the voltage divided by the only resistance, which is 9. So it will be 1 ampere. So those two branches will get cut out. Yeah, after a long time, then the inductor will behave like a closed wire. But this is how it behaves initially when it is just connected. Just connected. But after a long time, the same inductor will behave like a closed switch, or basically just like a simple wire. Okay, that's how it is. Moving on to the next one. The internal energy is given, 1 mole is kept, cross section is given, piston is given, gas is heated is given, temperature rise is given, piston will move by how much? Pure first law based question, and a little bit of other formulas also. Very good, Ranjit. Everybody understanding it. All these questions Very important. I know boards are round the corner, but people who ignore April attempt will ignore you. Simple. So we have heat is nothing but delta U plus your work done. Heat is delta U plus your work done. So where is that? Heat is given. How much is it? 126 joules. Delta U, we know it is 3 and RT. So 3, number of moles is 1. 1 mole is there. So 1 multiplied by R. R value we can take it as 8.3 multiplied by delta T. Delta T is 4. Okay. Plus work done. Work done is pressure into delta V. Work done is pressure into delta V. Is the pressure mentioned? Atmospheric pressure, yes. 10 raised to 5 into delta V. So what happens over here? This work is P delta V. Delta V means area multiplied by delta X. So pressure is there, area you put in. What is the area? 17 centimeter square. So 10 to the power minus 4. Delta X is the only unknown. Solving this, you will get the value of delta X. Okay. So the answer comes out to be 14.5. Yeah. So the piston will move 14.5 or 0.145 meters, which is 14.5 centimeters. That's all. So just pure application of first law of thermodynamics, like I said. Cool. Okay. Very good. Very good. Amazing. Amazing. Shall we go ahead to the next one then? Yeah, clear? Awesome. Let's go then. Here comes the next question on your screen. An air bubble rises from the bottom 5 meters deep. At the bottom, the temperature is so and so. The volume when it reaches the surface where the temperature is so and so. This question is purely based on gas law. Nothing more. Yes. Just pressure initially into volume initially upon temperature initially is pressure finally, volume finally upon temperature finally. The air bubbles volume is given initially, finally it is asked. How deep it is given. That means pressure can be calculated, temperature is also given to you. That's all. So when you are 5 meters deep, the pressure will be atmospheric pressure, which is 10 raised to 5 plus rho gh. Rho is 10 raised to 3, g is 10, height is 5. That is your pressure. Volume is 2.9, so just leave it as 2.9. We will get the answer also in cc. Temperature at the bottom is 17. 17 means 17 plus 273. Always put it in Kelvin. Will be final pressure when you come on the top will be atmospheric pressure multiplied by final volume divided by final temperature, which is 27. So 27 plus 273. That's all. Solving this, you will get the value of V2. So that is what is asked. What is the final volume of it? And the final volume comes out as 4.5. Okay, just check it out. Yes, it should come out as 4.5 centimeter cube. Yeah, don't have to convert it. Don't have to convert it into meter cube, guys, because this was also cc. This will be also cc. So that is the advantage which we get in such things. Okay. So direct application of gas law. Moving on to the next question on your screen. Yep. So these questions look big in the exam because it looks huge paragraph and people are used to small questions because you have been looking at 2021, 2022, 2023 papers. Even till 2024, the physics paper was fine. But in 2025, things change slowly. And 2026, obviously, things are on the higher side. Right. Suppose a long solenoid, radius, turns, current, omega, circular loop, coaxial, radius, velocity, my God, slided the RMS current through the loop when the coil is 10 centimeter inside the solenoid. Unnecessary lot of data, but not so much is required also. Because see, when you take it inside the solenoid, what is happening is the current is changing, because of which the field is changing, because of which the flux is changing, because of which the EMF is created. And once the EMF is created, there will be current which will be created. It's that simple. So if I want to find the current, it will be the EMF induced divided by the resistance of that coil. But the resistance of the coil is given to me. I don't have to worry about it. This will be nothing but d phi by dt, magnetic flux, which is changing. So 1 by resistance of the coil. Magnetic flux is magnetic flux is B into A. Area will not change. So it will be area of the coil which will be outside multiplied by dB by dt. Now, area of the coil as it is, resistance of the coil as it is. What is dB by dt? Well, magnetic field is because of the solenoid which is having that current. So mu naught N, number of turns per unit length, multiplied by the current in that solenoid. Now mu naught and N will come outside. Okay, so area of the coil, resistance of the coil, mu naught is outside, N is also outside, and di by dt will remain, but that current is exactly this, which is 10 sine omega t. Okay, perfect. So area of the coil, resistance of the coil, mu naught N is also there, 10 will come outside, even omega will come outside, and you will have cos of omega t. But I don't need all of that, because this is nothing but your maximum induced current, and we want RMS current. So IRMS will be whatever value you get here divided by root 2. So area of the coil, mu naught N 10 omega divided by resistance of the coil. That's it. So now all the values are given, just have to substitute one by one. Okay, so 1 by root 2, that means 1 by 1.414. Area of the coil, I think it is given somewhere. A circular coil of radius 1 centimeter. That means it is pi into 1 square, which means 10 raised to minus 2 whole square, multiplied by mu naught. Mu naught is 10 raised to minus 7 divided by 4 pi. No, mu naught by 4 pi is 10 raised to minus 7. So 4 pi into 10 to the power minus 7. So 4 pi into 10 to the power minus 7. Number of turns per unit length, 500 turns per unit length. So 500 over here multiplied by 10 into omega. So 10 into omega. What is the angular frequency? 1000. So 10 to the power 3. Whole thing divided by resistance of the coil. Resistance of the coil, resistance of the coil. Where is it? Resistance of the loop is 10 ohm. That's it. Solving this, you will get the RMS value. And that RMS value comes out as 197. Okay, you will get it as 197. But this is by root 2 microamperes. So that means you don't have to substitute this value. So just leave this as it is. So you are going to get 1 by root 2 into 197 into 10 to the power minus 6 amperes. So the answer that you want will be alpha, which is 197. Okay, so just have to calculate that part. Cool, guys. Yeah. So just unnecessarily calculative and lengthy, too many pieces of information given to us, but it's okay. Next one on your screen. There is a bob which is attached to a massless rod of length 1 meter pivoted at a point, and the distance is given. Okay, bob is kept at rest, smooth surface extends to a track, and it just manages to complete the circular thing. So I'll explain it to you in bit. So what happens is this potential energy will convert into kinetic energy. Masses are equal. The collision is elastic. So all the velocity will go here. So the potential energy will get converted into kinetic energy. Potential energy will be mgl 1 minus cos 60. Standard formula is half mv square. So mm cancels, g is g only, length is 1. 1 minus cos 60 meaning 1 minus half is half into v square. Half cancels, so v will be root g. Now because after this ball has to complete the circular motion, this velocity has to be root of 5g into radius. That's all. So root g will cancel. So you will be getting 1 is equal to root GR. So R will be nothing but or GR will be nothing but 1. So R will be nothing but 1 by 5. That's it. So R will be nothing but 1 by 5 meters, which is option 2. So for it to complete circular motion, standard formula guys, root 5 GR should be the velocity at the bottom so that it completes the entire track and doesn't leave contact anywhere, not just here, but even here or here or here. So if it doesn't leave contact here, it won't leave here also. So that's why root 5 GR. Next one, this question. Well, you should know a couple of things. Total flux was asked. So whenever you have a cube and a charge is placed at one of the corners, the flux through that cube is whatever charge is there by epsilon naught. Imagine 8 cubes surrounding it and that charge at the center of those 8 cubes. So it will be 1 by 8th of that. Similarly, if you have a cube and the charge is placed on the face of it here, half the flux will go here. Imagine another cube on this side, half the flux will go here. So the flux which will go will be charge divided by epsilon naught but into half. So in this case, the charge at the corner is 2q by epsilon naught into 1 by 8. This will be just q divided by epsilon naught into 1 by 2. So this is nothing but q by 4 epsilon naught. This is q by 2 epsilon naught. But we want the total flux. So 1/4 plus half is nothing but 3 by 4. So this will become 3 by 4 q by epsilon naught. Adding. Yeah, just adding both of them. So here you have to basically visualize 8 such cubes, guys. Yeah, you have to visualize 8 such cubes over here. The front also. That is a crazy diagram which will come out. So if you visualize it like that, then you will realize, yes, that particular charge is at the center of that big cube. So 1/8 of the flux will go here. Here you just have to visualize 2 cubes. That's all. And then you will realize half the flux is going through this cube. Okay. So good question. Usually they used to ask either this or this. Today they have asked both of them. Next one. The equation of electric field is given by so and so. The average power of the electromagnetic wave is 1 by a watt per meter square. The value of A is. So in this question, what have they really asked? Basically the intensity, the average power per unit area, watt per meter square, is nothing but the intensity of the wave. And intensity of the wave is half epsilon naught electric field amplitude square multiplied by speed of light. Everything you know, guys, nothing is there which is remaining. So they are given root of mu naught by epsilon naught. So why they gave it is because you can put speed of light as 1 by root of epsilon naught mu naught over here, and this is electric field amplitude square. So if you cancel it, you will get epsilon will cancel. You will have epsilon naught by mu naught into electric field square, and now you can solve it. So mu naught by epsilon naught root is 377. So this will be 1 by root 377. Sorry, 1 by just 377. And epsilon naught amplitude is root 377 whole square. So these both will cancel. So you'll just be left with half, which is nothing but 0.5. So that is the answer. Yeah, 0.5, which is the answer. Okay. They have asked what is the value of A. So technically speaking, this is the value of A. This is the value of A because 1 by A is the final answer. So A value will be basically 2. Okay. So this was the small manipulation which was needed. That's all. You use the speed of light formula as root of 1 by permittivity into permeability. And then you cancel it out, and they had already given this value. So calculation became little easier. They showed little bit of mercy on us, you can say. Okay, cool. Shall we go ahead? Moving on to the next question then. Ready for it? Okay. The reading of the ammeter in the steady state in the following circuit, negligible internal resistance, how much will it be? It is a simple series parallel circuit. These both are in parallel. So answer will be 4 ohms. This 4 and this 4 are in series. So this entire thing will become 8 ohms. Okay. So now you have basically a circuit of 1 ohm and 8 ohm and another 8 ohm. That's it. So this is 8, and this is 1. This is 8 ohm. This entire thing is 8 ohm. So guys, this 8 and 8 together, what will it be? This 8 and 8 together, what will it be? It will be 4 ohms. So 4 and 1 together, what will it be? 4 and 1 together, it will be nothing but 5 ohms. So EMF is 10 volts. So how much will be the current? The current will be voltage by resistance, which will be basically 2 amperes. So what will happen is indirectly 2 amperes of current will go here. Question is, what is the reading in the ammeter? So out of the 2 amperes, 1 ampere will go here. The remaining 1 ampere will go like this and come back over here. So 1 ampere here, and this will also have 1 ampere. They'll both combine and it will again become 2 amperes. So the reading will be 1 ampere. That is option D. Okay. Very simple series parallel circuit. Nothing great about it. Cool. Let's move to the next one on your screen. In a Vernier caliper, 50 divisions are equal to 48 main scale divisions. One main scale division is this much, least count. So 50 Vernier scale divisions are equal to 48 main scale division. One main scale division is 0.05 millimeter. So 1 VSD will be 48 multiplied by 5 0 into 10 to the power minus 3 divided by 50. 50 will cancel. So I'll be getting 0.048 millimeters. Finally, least count. Least count is MSD minus VSD, standard formula. Main scale division is 0.05. VSD is 0.048. So if you think about it, this is 0.050, 50 minus 48 is 2. So 0.002 will be the answer. 0.002 is the answer, guys. Standard formulas. Whatever is given, I have written it down. 50 Vernier scale divisions is 48 main scale division. How much is a main scale division? 0.05. So put 0.05. That's it. Whatever was given, I have written it down. So how much is 1 VSD? Take that 50 below. Then least count formula is MSD minus VSD. Okay, that's it. So that will give you the correct answer. Moving on to the next question coming up on your screen. Very good question, guys. This was on rotational motion, where there is a rod which is hinged over here. It is left, it falls down. Question is, what is the angular velocity? First things first, where is the center of mass? It will be somewhere here. This is where the center of mass will be. But how far is it? Okay, how far is it? Because this is L by 3, this will be L by 2. So that distance, if I call it D, it will be nothing but L by 2 minus L by 3. So that will be L by 6. Why is that needed? Because I know finally when this thing will fall like this and it will have some kind of angular velocity, the center of mass would have traveled like this and come down over here. So the loss of potential energy in the center of mass is equal to the gain of kinetic energy in rotation. Loss of potential energy is mg. It has come down by d height, which is basically L by 6. That's it, is half I omega square. The only thing now remains is, what is the moment of inertia? The moment of inertia by parallel axis theorem is moment of inertia about center of mass, which is ml square by 12, plus m into distance square, which is L by 6 square. Substitute it here, you will get the value for omega square, and from that you can get omega is equal to something. So the answer comes out to be root 3 G by L. Okay, so we'll get the answer as root 3 G by L. Okay, so I'm just showing you the methods. The catch was people ignore the distance and fail to find out moment of inertia, one issue. Second issue, they don't understand how do I use energy over here, because whose potential energy loss should I take? So you have to take the loss of center of mass's potential energy, okay? Because that will give me the entire body's potential energy. All right, let's move to the next one on your screen. This question kind of repeat, but also not repeat. Usually they ask one loop. Here they are given two loops, and there is a big catch towards the end. I'll tell you what it is. First, magnetic field due to this loop, magnetic field due to this loop, we can find it out using simple formula. Magnetic field due to P, is mu naught multiplied by current, which is I, divided by 2, and then you have identical loops, right, of radius r. So r square plus x square, here x is also r only, raised to 3 by 2, and there is r square over here. Similarly, magnetic field due to Q will be mu naught, current is 4I as given in the question, divided by 2, radius is still r only, multiplied by r square plus again r square whole raised to 3 by 2. Okay, standard formula. But the catch is towards the end. It is clearly mentioned, it sees point O will see the current clockwise, meaning if you are at O and looking at this loop, clockwise current means it is like this. And if the current is clockwise, curl your fingers, you will see the magnetic field should be going this way. So due to P, the magnetic field will be like this. From point O, if you look at Q, clockwise current, it should go like that. Okay, it should go basically like this. And if you curl your fingers, you will realize the magnetic field is actually this side. So when you try to calculate the net magnetic field, basically it is BP minus BQ. Many students thought, sir, it is clockwise. No. So clockwise means same direction. That means same direction of field. So it will add. So many people put a plus sign here, but they fail to realize you are not seeing it from here. No. Then the answer will be plus. The small difference which made in this problem was the point where you are seeing it is from point O. So when you see this coil, it looks like this. When you see this coil, it looks like this. But understand, both of them will be in opposite direction. One is going like that, one is going like this. So because of which the fields will end up opposing each other. So the difference will come over there. How many of you realize this during the exam? Because that is what is the tricky part. Okay, amazing. So solving that, you should get the answer as option D, which is towards Q. Okay, I just shown you the catch of the problem because that is more important than the complete solution. Moving on to the next question on your screen. There are two reactions given, nuclear reactions. Compare the stability. If somebody is releasing energy, meaning you are becoming stable. If somebody is absorbing energy, that means you are becoming unstable. That's all. Yeah. So over here, because energy is released, 100% energy is released. That means 4He2 is more stable than 3He2. It is more stable. Because energy is absorbed, because negative is there. Therefore, as compared to 4He2, energy is absorbed. That means this is becoming unstable. Is that right? Yeah, this is becoming unstable. So 4He2 is going to be stable than 5He2. Okay. But the problem is the amount of energy is involved. Here, more energy is released. That means this is more stable. I will say greater than as compared to this, because very little energy difference is there. So yes, this is stable than this, but not by so much. So now if you compare, you will get the answer that yes, this is the most stable. There is a huge difference. This is not so much difference. So 4He2 Okay, this difference is not large, is more than 5 He2, and this is more than 3 He2, because this is bigger than this is also bigger than this. I do not know the comparison between them, so I got that comparison by looking at these numbers. 20 is bigger than 0.9, so that's why more than. Getting my point? Okay, so that's how I write it. And then 4, 5, 3, I think they had given 4, yeah. So this will be x4 more than x5 more than x3. 4, 5 and 3. 4, 5 and 3. Perfect. That is the correct answer. Cool. Yeah. Many kids did not realize in the exam, how do I compare this 3He and 5He? So, the challenge was over there. So they wanted you guys to think about it. Yeah, such a beautiful, beautiful question. Moving on to the next one. A flexible chain hangs between 2 points. The inclination of the chain with the horizontal is 30 degrees. Consider the equilibrium, the tension. This was a question which was asked long time back in JEE. Now they have again repeated it. So wanted you to recollect how to solve it. So first of all, here the tensions will be different. And let's say I call this tension T1. The inclination of the chain with the horizontal is 30 degrees. So this is basically 30 degrees. So what happens is, first of all, if you see tensions sine 30 component, and here also the same tensions sine 30 component together will be balancing the entire weight. So 2T1 sine 30 is equal to mg. Sine 30 is half, so T1 will be basically mg. Now what you do, because you want to find the tension at the lowest point, just consider half of the string. And remember, tension always acts along the string when you draw a tangent. So when you draw a tangent, it will be like this. So this is T1 and this is the tension at the center. So if you take the cos component, so this is T1 cos 30. So T1 cos 30, which is root 3 by 2, will be Tc. T1 is nothing but mg. So mg root 3 by 2 is the tension at the center. So that is why you will get mg root 3 by 2 as the final answer for this particular question. Catch is tension's direction. So tension will always act along the tangent drawn to the curvature of the string. Okay, so at the lowermost point it will be horizontal, at this point it will be at an angle, whatever angle the string makes. Okay, nice concept. I hope you remembered it now. Okay, so that's all that was there in this question. Moving on to the next 129th question on your screen. The exit surface is coated with some material. When the prism is set for minimum angle of deviation, it exactly meets the condition of critical angle. So when the prism is set for minimal angle of deviation, it meets the condition for the critical angle also. Okay, because the coating is lower refractive than the material of the prism, so we can first figure out what is the critical angle of incidence. That will be higher refractive index by lower refractive index. Sorry, my bad. Opposite. Lower by higher. So lower by higher. So that will be half. So therefore critical angle will be 30 degrees. Okay, but we do not have to end over there. See, I'll tell you, just draw the diagram, things will be very clear. This is coming like this. Now, this critical angle will also be R2. So this will also be R2. And for minimum angle of deviation, R2 will be equal to R1 because minimum deviation is occurring. Once I understand what is R1, R2, I can also get A, which is angle of prism, which is R1 plus R2, which will be 30 plus 30, which will be 60 degrees. The prism angle, oh, that's it. The prism angle is 60 degrees. That's all. I mean, nothing great. I thought incident was asked, but no, that was not even asked. So the angle of prism is asked. So once I know R2, I know R1 will also be equal because of minimum deviation. And there you get it. So geometry involved. Like I said, there were a couple of geometry based questions asked multiple times. Moving on to the next question. There was a microscope which was given. Again, microscope coming 2 times, guys. Length of objective and eyepiece is given, or focal length. Magnification for normal adjustment is how much? Same thing repeated 2 times. Yeah. So what is the magnifying power, guys? It is magnification of the objective, which is length of the tube divided by focal length of the objective, multiplied by, for normal vision, least distance of distinct vision divided by focal length of the eyepiece. This is the formula. If you know it, you are done. If it is least distance of distinct vision kind of arrangement, then 1 plus will come. But for normal vision, only d by f will come. Length of the tube is 10. Focal length of the objective is basically 2, let's say, and this is 25, and this is 5. 25 by 5 is 5. This is also 5. So 5 multiplied by 5, which is 5 raised to 2. So the answer will be basically your number 2. Okay. Yeah, that's it. 100 in Jan attempt, Aditya. Please watch my strategy for April attempt and make sure you make that comeback very soon. Okay, I've given every single detail. More sessions will follow. Keep watching these classes along with your board classes. Next one. Unpolarized light, refractive indices given. To satisfy the condition that reflected and refracted rays are perpendicular, the angle of incidence is. This condition happens in a very peculiar scenario. So imagine reflected ray and refracted ray both are perpendicular to each other. This happens only in one scenario, when this angle of incidence is Brewster's angle. Then unpolarized light becomes polarized. This is partially polarized here. So this is basically concept of Brewster's angle. That's all. So tan of the Brewster's angle is the refractive index. So refractive index, the outer one will be rarer, the inner one will be denser. So having refractive index of 2 and 2 by root 3, 2 root 3, sorry. So 2 root 3 divided by 2, so that will be root 3. So that angle will be nothing but 60 degree. So 60 degree is the right answer, option A. Yeah, directly. So this mu in this case will be the relative refractive index, else it would be just the refractive index of that glass or the water. In this case, it will be relative because both the mediums are different. Yeah. Potentiometer is not there in the syllabus, but they have asked 2 times the questions on potentiometer, which was very strange. It should be challenged. It should be challenged, man. Yeah, potentiometer is not a part of the syllabus. Next one. On your screen, here it is. There are 3 concentric conducting spherical shells and are charged with Q1, Q2, Q3. The potential of the spheres are. Okay. So let me first draw it. It's purely conceptual. The options are scarier than the concept. Concept is simple only. A, B and C, radius A, B and C, C is the largest. So C is the largest. Okay, Q1, Q2, Q3. This is A, this is B, this is C. Okay, so how do we do this question? Potentials of sphere A. When you are talking about potential of sphere A, then you are inside all the spheres, inside all the shells. You are inside for all the shells. So whenever you are inside a shell, the potential is kq by the radius of the shell. So it will be nothing but k q1 by radius of that shell, which is A, plus k q2 divided by radius of that shell, plus k q3 divided by radius of that shell. Direct formula. Okay. Then let's say we are on shell B. We are on shell B. You are in for B and C, but you are out of the shell A. So the potential of the shell B will be, because you are inside B and C, the potential will be kq by radius of the shell plus kq divided by radius of the shell But when you're outside, the formula is kq by r. So for outside for A shell, so k into charge on A divided by distance. The distance you are at is basically the radius of shell B. So B will come over here. Okay. So when you're inside, it is kq by radius of the shell. When you're outside, it is kq by r. So that is the formula, guys. When you are inside, it is k multiplied by charge by radius of the shell. When you are outside, it is kq by the distance from the center. In this case, the distance from the center is the radius of the shell B. So that's the formula. And same thing you can do it for here. When you are here, at this point, you are out of all the shells. So it will be k q1 by c plus k q2 by c plus k q3 divided by c. That's it. So that is the answer. Yeah. K is 1 by 4 pi epsilon naught. Option C. Option D, sorry. Cool. Shall we go ahead to the next one on your screen? This particular question, guys, let's try to solve it. This is also a good question. Block on block on block. But the good part is when you pull this, both these blocks will move together. So consider this as a system. So actually speaking, there are only two blocks. Nothing actually was said about A and B, but I'm guessing they will move together. That's what was expected, else it will be very weird. Okay. So the total mass of both of them will be how much? 10 kg. So 10 kg. So the normal that they will experience will be 10 g. So the friction that will come, the friction that will come due to A and B together will be mu into normal. Mu is 0.5. Yeah, mu is basically 0.5. Normal is nothing but 10 g, which is 100. 100 into 0.5 is nothing but 50 Newton. Now, when you just consider for the block C, the normal which it experiences will be the total weight which will it balance. So the total weight, this normal will be 10 plus 8. So that will be 18 g. So the friction at the bottom surface of C, which is again mu into n, mu is 0.5. This is 18 g, which is 180. So that will become 90 Newton. Now see guys, what will happen? If you consider A and B as a block together, it will try to move here. It will try to move here because of this particular tension. And the friction which will balance it is nothing but 50 Newton. It will try to move here. So it will be opposed like this. This is A and B together. Whereas if you consider our block C, again tension is there over here. The friction on the top face will be like this. On the bottom face also will be like this because it is trying to move over here. And this bottom friction is 90 Newton. And you are applying a force of F. That's it. This is how the free body diagrams will look like. Now it's just a matter of writing the equations. So in the first case, my tension will be equal to 50. So this tension will also be equal to 50, I suppose. Yeah, because if this goes like this, the friction will pull it like that. Okay, friction will oppose like this. Perfect. So tension is like that, right? So my force, which is there, which I'm trying to pull over here, I'm not only balancing that 50 plus this tension, which is 50 plus this 90, which is basically 190 Newton. So that is the answer, 190 Newton. You can follow my Rohr series or even the older series. 120 is not a bad score, man. Jan 28 first shift was a decent shift. Okay. Yeah, you can follow my older classes for concepts or even Rohr series. Both are fine, man. It's completely up to you. Rohr is also good only. Okay, you can watch. Anything is fine. And it's just the style and the questions are different. So one thing you can do is just check out the different questions. Don't see the theory part again. Whenever I'm doing questions, just see the questions because the questions which I have done are completely different. Okay, so you'll get more variety, more practice. That's all I will say. Next one on your screen, this one. This block sliding and the wedge is being accelerated. Find the time it takes. All right. First of all, only because of gravity, gravitational acceleration is down. Gravitational acceleration is down. Only because of gravity, the acceleration that it will encounter will be g sine theta. Is that right? Because the wedge accelerates here, it will experience a pseudo gravity like this. It will experience a pseudo force like this, pseudo gravity like that. So the component along the incline will be a naught cos theta. So the net acceleration that it will experience, will be g sine theta minus a naught cos theta. Is that clear, my dear warriors? The net acceleration that it will experience because of gravity, g sine theta, because of pseudo forces component along the incline, it will be a naught cos theta. That's all. Once I get this, my job is done. I will use S is equal to ut plus half at square, because they have asked what is the time it takes. The displacement, well, think logically. If this is L, this will be nothing but L divided by cos theta. So this displacement is L by cos theta is equal to u is 0 plus half into acceleration is g sine theta minus a naught cos theta. This whole thing multiplied by t square. So from this you will get t square is equal to 2 times of L divided by g sine theta cos theta minus a naught cos square theta. This is what you should get. Just take this out. 2L, yes, G and this thing T square. Now I can see sine 2 theta and cos 2 theta because deliberately they have done it. If you multiply this by 2 and divide by 2, this is nothing but going to be how much? This thing is going to be sine of 2 theta and cos square theta, guys. 2 cos square theta minus 1 is cos 2 theta. So cos square theta, I can always substitute it as 1 plus cos 2 theta divided by 2. Yeah, 1 plus cos 2 theta divided by 2. So when you do that, that 2 will go on the top and you will see that number 4 coming in. So I think it should be, yeah, one of these answers. Just check this out. Yeah, everyone? Perfect. Cool. Okay, so just have to substitute. That's all. Nothing else. Moving on. Next one. Two masses spring. What is the angular frequency? Angular frequency is root of k by m. K already given 150, but this m is not any one of the masses. It's the reduced mass, which is m1 m2 divided by m1 plus m2. So it will be 1 into 0.2 divided by 1 plus 0.2. That's how you do this. So whenever you get two masses oscillating like this, you will take both the masses as one single mass, that is called as the reduced mass. You are reducing two masses to one, and that reduced mass formula is like resistors in parallel. So m1 m2 by m1 plus m2. So do that, you will get the answer directly. Okay, cool, everyone. So the answer comes out to be 20. Yes, solving this, you will get the answer as 20, yeah, radian per second. Moving on to the next question on your screen. For a transparent prism, the angle of minimum deviation is equal to the refracting angle. The refractive index is the angle of minimum deviation is equal to the refracting angle. That is what is given to us. The question is, the prism satisfies refractive index. So refractive index is related, guys. Remember, refractive index is sine of a plus delta minimum by 2 divided by sine of a by 2. So this will become sine of a plus a divided by 2 divided by sine of a by 2. Correct? So this is nothing but just sine of a. This is nothing but just sine of a. And this is nothing but sine of a by 2. So what can we do ahead? Think about it. I think I can use double angle formula. So therefore n will be 2 times sine a by 2 into cos a by 2. divided by sine A by 2. Sine A by 2 will cancel. So I will get n by 2 is equal to cos of A by 2. I think now I can do something because inequality is there. I know cos of any quantity, doesn't matter, will always be less than 1 and more than 0. Yeah, but okay, so if I know that, then I can say n by 2 will be less than 1 and more than 0. That means if I multiply both sides, so 0, n and 2, but I know n is not going to be like 0.1, 0.2 refractive index, but refractive index is always going to be more than 1. So therefore, here I can put 1 and then I can put 2 over here. So I can reduce that range. So 1 less than n less than 2, which is option B, I believe. Yes, that is the right answer. So once I know this, I use this because refractive index is compared. And once I got it, I know trigonometry wise, angle of any cos will be less than 1 but more than 0 for normal ranges. Yeah, it can be more than -1 also, but I will not take negative values because refractive index can't be negative. So that's why I took it more than 0, because this will be in maximum your first quadrant to second quadrant, correct? So in from first quadrant to second quadrant, that's all. Yeah, perfect. Moving on to the next question. Electric current is given by so and so ERMS, the EMF current. I think the RMS current was asked, not EMF. This was RMS current, not EMF current. RMS current. Yeah. Yes. Everyone, are we applying pseudo force because the ground is the observer? No. We are applying the pseudo force because we are sitting on the wedge. So from the wedge, POV is from the wedge. Pseudo force will only come in a non-inertial frame because this length will be observed from the wedge. If you are on the ground, then the particle will move very differently. It will not move along the incline. It will have, very weird motion. So we are not seeing it from the ground, seeing it from the wedge, non-inertial. That's why opposite pseudo force, a component which countered the component of the gravity. How do I solve this? Simple direct formula. IRMS square is integral current square dt divided by the time period. That's it. So 1 by t is here. Current is nothing but I naught small t by capital T, but this whole square dt. So this will become I naught square by t cube and integral of t square dt, which is I naught square by t cube, 0 to t of course. So this will become t cube by 3. T cube cancels, so it will become I naught square by 3. So IRMS will become root of I naught square by 3, which is I naught by root 3. So I naught by root 3 should be the answer. Yes, option D is the right answer. Okay. So these were some of the questions, guys. Let's go to the next one on your screen. Water is falling from a tap 5 meters below, and when the first drop strikes the floor, the sixth drop is beginning to fall. Usually we have done these questions for 2 or 3 drops, but here they had given, like sixth drop is over here. This is the sixth drop, and this is basically your first drop. So 6 to 5 to 4, 3 to 2, second, third, fourth, fifth. So you can clearly see how many time intervals are there. How many time gaps are there between successive drops? These are not heights, these are times. So 1, 2, 3, 4, 5. So 6 drops means 5 time intervals. So 5 into time is the time of the entire fall, which is root of 2h by g. So this will be 2 multiplied by height is 5 divided by 10. So it is 1 second. So that is 5t. So t is basically 1 by 5, which is 0.2 seconds. Now, because they have asked at what height will the fourth drop be, first figure out what is the displacement of the fourth drop using ut plus half at square. Initial velocity 0, acceleration is 10. Time will be, for fourth drop, how much time would have elapsed? 2t. So basically 2 into 0.2, which is basically 0.4 square. So this will just become nothing but 0.16. So 10 multiplied by 0.16 divided by 2, which is 0.08. So it will become 0.8 meters. That is the displacement. But they have asked it from the ground level. So this height they have asked. So that will be the total height minus 0.8, which is 4.2 meters. So 4.2 meters should be the correct answer. Okay. So here when I substitute the time for fourth drop, 1 and 1. So 2 time intervals are over. 1 time interval was 0.2 seconds. So I have substituted the time as 0.4 seconds, guys. Okay. Cool. Let's go to the next question. Question number 39. Last few questions are remaining, I think. Okay. An atom is bombarded with multiple particles, 10 electrons, 10 protons and neutrons, percentage growth in the surface area. How does the surface area depend on the nucleons? It depends on the number of nucleons. Remember that area is 4 pi r square, and do not forget the radius. This is the surface area. I'll put S symbol. The surface area S. Radius is r naught, a raised to 1 by 3, a being the number of nucleons. So it will become 4 pi r naught square into a raised to 2 by 3. So we just need to figure out the number of nucleons then. So earlier there were 8 nucleons. Now electrons will not affect it. Electrons are not going to be inside the nucleus, but this one, these 10 protons and 9 neutrons. So the final number of nucleons will be, earlier there were 8. This 8 is the initial number of nucleons plus 10 protons and 9 neutrons. So that will be nothing but 27. Okay. So from this, I can write down S1 will be 4 pi r naught square. Initially it was 8. So 8 raised to 2 by 3. S2 will be 4 pi r naught square. Finally it was 27 raised to 2 by 3. This is some constant, forget it. So I'll just put it as constant. 8's cube root is 2. So 2 square is nothing but 4. 27's cube root is 3. 3 square is 9. So C into 9. So percentage change in the surface area will be S2 minus S1 divided by initial multiplied by 100. So S2 is 9C minus 4C divided by 4C multiplied by 100. That's it. So this is 5 by 4. So 5 by 4 multiplied by 100. 100 by 4 is 25. 25 into 5, which is 125%. So 125% should be the right answer. That's it. The percentage change will be 125%, but I think they have asked something else maybe. Have we missed something? Just see. 9C minus 4C by 5 by 4. Initially it was 4 only. Just check this out. Have we missed something? Just check, guys. Have we missed? The percentage growth in the surface area. If percentage change is asked, that is right. But if they have asked what is the final upon initial, then it will be different maybe. If they have asked only this much percentage growth, I think what they mean is here, which is ambiguous again. Growth, what do you mean by that? Final upon initial. So I think they should have mentioned it a little bit more clearly, or else it is very ambiguous, guys. Okay, so maybe this is 9C divided by 4C multiplied by 100. Then this will become 25 into 9, which is 225%. So if that is what is being asked, yeah, then it is 225%. Else percentage change will be 125%. So maybe that growth is like how many times are you now versus before. So then yes, it makes sense. Otherwise, no. Okay, perfecto. Shall we go ahead to the next question on your screen? Here it comes. Yeah, this is the next question. Assuming, yeah, the last question. Assuming in forward bias, there is a voltage drop of 0.7 volts across a silicon diode, the current through diode 1 in the circuit is how much? The current through the diode 1 in the circuit is how much? Okay. See, this diode is going to be in reverse bias, so forget it because this is reverse. So no current will flow. So whatever current has to flow will come here and it will get distributed in both of them equally. So let's say this is I, this will be 2I. Okay, but the drop over here is 0.7 volts. So from 12, 0.7 volts is dropped here. So how much voltage will be dropped? 12 minus 0.7, which is 11.3 volts. Now from that we can find out the current. 2I will be voltage by resistance. Voltage is 11.3, resistance is 0.3 kilo, so 10 to the power 3. So that is 2I. So from this I will be 11.3. This will be nothing but 300 and into 2. So that many amperes. So just check it out if you are getting it as 18.8 in milliamperes. So this was in amperes. So 11.3 multiplied by 1000 divided by 300 multiplied by 2. This will be milliamperes. So you should get it as 18.8 milliamperes. Just check it out. Okay, that's all. So that was your final question, my dear warriors. And I hope you enjoyed this session a lot with these top 40 questions for all of you for your JEE Mains April attempt. Okay. All the best. Keep watching, keep learning, and keep guided. Keep getting guided. Okay. On this channel. Thank you for liking this video and sharing this. This was your Captain Shreyas.